The phase diagram is like a map. It tells us, based on the percentage of components and temperature, what the mixture will be like. As in most cases, if you get hot enough, the mixture melts. So if we look at the phase diagram for tin lead, which is common solder, at higher temperatures, the mixture is a liquid. When the mixture is almost entirely lead, it's a single component called alpha phase. This dark blue region is the alpha region. It's called homogeneous, meaning all of one type. When the mixture is almost entirely tin, it's a different structure. We call it beta, and that's this dark blue. When the mixture is partly one and the other, that's these white regions. Our textbook, Shackleford's Introduction to Material Science for Engineers, uses white to indicate a mixture of two types of elements, or two types of structure. So what does it look like when we're in one of these regions where we have both alpha and beta present? Well, that's shown at the beginning of chapter 9 in this figure. What we discover in nature is that the alpha regions will form together in this black stripe. That's the lead-rich area, while the beta regions form their own small homogeneous sections, this white region, which is the tin-rich area. So if we go back to the diagram, we can see that if you know the percentage of tin, 60% tin, 100 degrees centigrade, that will tell us it's a mixture of alpha and beta. And the only other thing I'll point out about this diagram is that usually the lower axis is given in terms of weight percent. Weight percent is easier to measure, so when you're building an alloy, it's easy to measure so much pounds of lead, so many pounds of tin. But the atomic percentage is something different because the lead atoms are much heavier than the tin atoms. So even if you have 50%, or if you have 50% tin by weight, you'll have far more tin, 63% or so, by count of atoms. So once again, the phase diagram is a map that tells us, based upon the composition and the temperature, what our mixture will look like.